I'm going to go ahead and try to clean up some of these really poor solder joints. And the first thing is to basically get the solder off the board. As best I can. These don't look too horrible. These don't look great at all down here. Of course, that capacitor fell right out. Clear, and it did. So that was this little guy. And of course, there's a lot of thermal mass there. A lot of copper where he was in. So I'm going to go ahead and put him back in, and luckily the PCB is silk screened. I'm going to assume that the capacitor that came out is the proper one. No guarantees of that. Flay the leads a bit here. I may need a more significant tip on the soldering station, so I'm going to hot swap the tip here. This is significantly bigger. It's got a lot more thermal mass to it, so it'll transfer heat much better. Getting cleaned up, tinned. The soldering station is set to 350C. He's in there okay. I saw that pull through to the other side nicely. I'd like a little more solder on this side. And he's in. I can see that the solder has flowed through the other side of the board, and he seems to be in there well. So let me find the flush cutters. There was a lot of extra lead length on one side. And remove him. We hit a solder joint up here as well. It was for a resistor. Get all the dead solder off. I will touch that up with a pencil. Yeah, that's taken a fair amount of time to heat down through. I've at least got a decent looking solder joint. Sorry, I'm off camera. The solder joint looks a little better. It doesn't have that big ball that it had on the end of it. We've got this mess down here. That is going to be for this capacitor. Let's go ahead and just get the old solder off, and the cap actually, not sure what just happened there. It's almost like there's no lead through the board. Oops. Yeah, that's pretty piss poor. The leads were trimmed very short on this capacitor, but I can see that they're both in place, so I'm just going to go ahead and leave him hanging, and I will just retouch up the solder. Definitely taking a fair amount of heat there. That's not a gorgeous solder joint. That one isn't requiring as much heat. This certainly did not flow through well. I've harped previously on dwell time. That was a fair amount. He feels solid. I don't have what appeared to be a cold solder joint there. I know there was a couple others that I thought were suspect. We need to clean out the holes where I pulled those two large, what I'm assuming are filter caps out of. That's cleared, somewhat cleared the holes. That didn't clear really well on this side. So let me get some fresh solder on the tip, and I will. That's much better. I can see through all four of the holes now clearly. Back in, clean the excess solder off the leads, make it a little easier to get it down through. Again, these are very suspect capacitors to me. So, as I remember, the negatives were on the outside. Sorry, I'm struggling to get a position where he'll go in. It's hitting up against that choke. Certainly not pretty. And of course, I'm working off camera. I'm going to flay the leads out a bit just to hold him in place. Negative was to the outside. And negative was to the outside in my drawing. Let's go ahead and see if we can get a little better solder joint. This has got a lot of thermal mass to it here. Yeah, that looks a lot better. Now it really becomes repairing the PCB over here. I still haven't really decided how I'm going to do that. See, the cap was 3300 microfarad, 16 volt. I'd like something with longer leads that I could sit in here on its side, and that would give me access to everything. So let me go see if I've got something in that range. I'm sure this is just a bulk filter cap. Go take a look over here at the caps. This just assumes I can find the electrolytics. There's so many boxes of parts over here. Tail regulators, heat sinks, lots of knobs. I don't think there's going to be anything in this kind of rating. Really isn't. This box might get me close. I'm not so worried about matching the capacitance exactly as I am about voltage rating. There's a 2200 microfarad, 1500, 1,000. Those are cheap Chinese. I'm not going to put that back in there. $470. These guys are rated. 1,500. So this is 2216 volt. I'm going to just make an assumption here that 2216 volt is a close enough replacement, at least to attempt to get the board to work. There's this lifted foil here which came over to this resistor, and I am just going to cut that foil out of there. Like so. There it is. And let's see how to approach this. I think he's going to lay in there this direction. So let's see, negative needs to be the outside. I think he's going to lay in here this direction. I'm going to take the positive lead and I'm going to bend it down. Now this is not going to be the most robust fix here. I suspect I didn't leave myself enough height there. I didn't. Straighten that back out. For what I'm attempting to do here, hopefully that gives me enough height now that it can sit on top of the resistor. Get good solder contact with the resistor. It's going to come to about there. And it's going to flex to the right. It's going to sit in there like that. Trim this lead about that length. I'm going to get the remains of there. It fell out. Hopefully it fell out. The remains of the lead. Here it is. So that's been cleared. Square. So he's going to sit in there. And we're going to take the negative lead. We're going to bend it down. Like so. Not looking too bad. I don't know how much of this you can see on camera. It looks pretty good right there. So what I've done is this capacitor is going to sit on top of this resistor. This neck and the bend right here, this corner is going to solder onto the resistor lead. This metal along here is going to replace the PCB trace that's missing. The tip of this lead is going to solder up to this pin number 2 on this hybrid array. and then the negative lead will just drop through the hole and be soldered in normally. If I was going to leave this in here as a long-term fix, I would definitely hot snot it in place. You can see it's certainly not a pretty fix. Let me get some tinning on the one set of leads, just so it'll be a little easier to get it in place. This is certainly just going to be tacked in place and not a great mechanical fix. But really, I'm just after enough here to see if there's signs of life. I don't want to generate a short here. I might have that a little too long. Do a bit of bending the stuff around here. Okay, that's on top. Now where I want it to connect, we'll let solder down in, and it did. It's certainly not pretty. Can I get you to flow from this side of the board? That's not a good looking solder joint. You came through there and you're not really looking soldered well on this side. It's actually surprisingly solid in there. I'm going to come back now to the original solder joint I did here, and that's where I tack soldered that to the resistor lead. And I'm going to reflow that just because there's been a fair amount of mechanical stress, and I did see the mechanical stress release when I heated the solder up and the capacitor moved slightly. So as not pretty as that is, that's the fix. I'm going to add some mechanical stress here and slightly bend that up just to air gap it. So no, that's 1100 microfarads less than we really wanted there. Like I say, I'm guessing based on the sizes of the traces that was power. It was just a filtering cap. Same with this guy. The power supply I'm going to be used to temporarily power this thing up is a real high quality linear DC power supply. It's one of my Rigals, so it'll produce nice clean power. It's not a switcher, so I think that should work okay. So should be coming out of the Commodore A500 power supply, the big brick. I don't know how clean the power getting out of there is. I'm assuming these large filter caps here to simply help deal with that. Of course, I don't know that. The only schematics I found are A500/2000, and the part numbers didn't seem to line up well with the part numbers here. Boy, that shield ground there is really ugly. So I kind of addressed a couple of spots down here somewhat. That's really not pretty, but it's okay for now. We touched this back up. Just put him back in where he was. So really, I think the next step for me is to Figure out how I'm going to get power in the jack here, whether I'll solder up something with pins or tack wires directly to the board. Like I say, the goal here is just to see if this thing spits out video. If it does, I'll then think about taking this further to get it back to a completed system. Again, I'm just visually looking, you know, I haven't seen any signs of corrosion. It's not like there's been a expansion memory card on here with an RTC that's, you know, the battery's leaked and the acid has, you know, found its way up and etched. The pins are all nice and clean. There's no real evidence of, you know, even the cap I put back in, he's not bulged at all. He's probably just nice and dry and not filtering really well. So, oh, this is a Rev 5 board. I was curious about that. And of course the Rock Lobster stuff is all covered up by the sticker here. That's kind of sad. Again, just visually while I've got the tools hot. That's not a very good looking solder joint there. Hasn't flowed well through to the other side of the board. Again, that's a place where somebody has reworked. So I'm going to put a bit of heat on that and hopefully get it to flow all the way through. Yeah, I've got, what was this guy, right? No. Or yes. I've definitely got shiny, nice solder that's flowed through the other side. Not excessive amount, but definitely know it's soldered through. That is just so ugly there every time I look at it. That little spiking cap, and it's because of the amount of heat it took to tack that in. The connection's solid. I'm okay with that. Some hot snot could make that a somewhat longer term fix. Of course, getting right size capacitor in there at some point would be better. You can hear how creaky the sockets are. I will of course reseat all the chips before applying power just to remove that as a variable. You know, I've looked at the leads several times. Oh, there goes Rosie in the background. No corrosion on the leads. They don't seem to be suffering from pin rot. They're all turned black and tarnished. Oh, Rosie. Rosie. Just going to look at a little something here, get on continuity. Try not to drop random ICs onto the board. I assume all these shields are connected together. I'm guessing that doesn't go to ground. Oh, Rosie. Collapsing trachea, common in small breeds. Really difficult to have to hear. So that seems to be a ground right there. Let's actually look at the pin out. Yep. So looking at the pin out, ground is there, and that should be ground on that side. +5 if I can get to it, should be there. If I get to a TTL device, well, you heard it for a second. I'm not making contact down in here again. Am I charging a cap up here, perhaps? Or just not getting good contact? No, I'm charging a capacitor up someplace. Oh, that's shield. Notches up. +5 is actually over on this side. I can't really see down in there to get to the pin. That should be +5. It's difficult to get down into. So that's what I thought. This cap right here is just a bulk filtering cap on the +5 rail. I suspect this one's a bulk filtering cap on the +12 rail. So let's see what that connector spun around that way. +12 should have probably ended up right here. Or have I got that backwards? Is that +5 again? Where's the other cap I mucked around with? I heard it charge. Okay, so those two, by all appearances, these two, the two 3300 microfarads are 5-volt bulk decoupling. The hybrid sitting here, pin 2 appears to go to +5, and it does. So yeah, these appear to have both been bulk decoupling, so I really don't have a problem losing the 1100 microfarads out of a 6600 microfarad stack here. They're in parallel. So it's just an interesting layout. But we should be okay there. So I think the next step here will be figure out how to route power down, get a composite monitor hooked up, and see if it does anything.